What are position vector? The position vector defines the displacement of a point from the origin, and it can be used to calculate distances, angles, and perform various other geometric and physical calculations. It is an essential concept in the field of physics, engineering, and computer graphics. Okay, let's try to understand what a position vector is. So if I consider a arbitrary vector, this vector, let's call it the vector A. So it has got an initial point and it has got a terminal point. Now, if we consider the initial point to be coinciding with the center of a coordinate axis or the origin of a coordinate axis, then this vector A is going to be then referred to as the position vector. That means, so here, if we consider the x and the y coordinate axis with the origin O, then we see here that the vector A, its initial point is coinciding with the origin of the coordinate axis. Then in this particular case, this is going to be referred to as the position vector A. Fine. Similarly, we can define other position vectors. So let's say we consider another vector B. Now this particular vector B also has its initial point coinciding with the origin of the coordinate axis. So in other words, a position vector is going to be a vector whose initial point coincides with the origin of a given coordinate axis. So here it's defining the displacement of a point. So if we consider the tip of the vector containing the position of the particle, then it talks about at what distance it is from the origin and at what angle it is with the respect to the x-axis the given point is. Okay, now what is the use of or the advantage of using a position vector? Now let's say point A corresponds to the position vector A and point B corresponds to the position vector B. Now we want to, let's say, define a vector going from point A to point B. Now, as we want to define a vector going from point A to point B, we are going to describe it with an arrow going from A towards B. So here we have AB vector. Now we can define this AB vector with the help of the position vector. Okay, so let's try to understand how to do that. What we'll do here, we will use the triangular law of vector addition. The triangular law of vector addition says this: if we consider this triangle OAB, so let's say in the triangle OAB, applying the triangular law of vector addition, we have OA vector added to AB vector. This is going to give us the vector OB vector. Now, since we need AB vector, so AB vector is simply going to be defined as OB vector minus OA vector. So this is what? OB vector is nothing but the position vector B and OA vector is the position vector A. So that means for defining the vector AB, all we have to do is consider the position vector B and from it subtract the position vector A. Or we can simply say we consider the position vector of the head, and here our head is going to be the terminal point of vector AB minus the position vector of the tail. So tail is going to be the initial point of the vector AB. Hence, we can say that if we have, let's say, any arbitrary vector, let's call it the vector AC. We have AC vector. Then AC vector will be defined as simply take the position vector of the head, which is going to be given by OC vector, minus the position vector of the tail. That means we have OA vector, and that is how we can define the vector AC. Let's try to understand this idea with the help of an example. So here in this problem, we are given 4 points A, B, C, and D, and each of the points are defined by the position vector A vector, B vector, 2A vector plus 3B vector, and A vector minus 2B vector. So we need to show that DB vector and AC vector are given by the respective vectors. Okay, let us begin. So first, we are going to represent the point A with the help of a position vector. So point A means we can convert it to a position vector as OA vector. This is equals to A vector. This is given to us. Then we have position vector of point B. This will be defined as the vector B vector. So it's given here that this is the vector B. Then we have OC vector. This is going to be the position vector of the point C. It's given here that this is 2A vector plus 3B vector. And then we have the position vector of the point D. So that will be OD vector given by A vector minus 2b vector. Our goal will be to show that db vector is given by 3b vector minus a vector. Okay, let's try to find out the db vector. So db vector will be defined as, we'll have to look at the head first. So that means we'll consider the position vector of the head, and from here subtract the position vector of the tail. So the tail is going to be OD vector. Now let's use the value OB vector, that's B vector. And what's OD vector? So that's A vector minus 2B vector. Now that means we have B vector minus A vector. The negative of negative 2b will become positive 2b vector, and this becomes equals to 3b vector minus a vector. So we have shown that db vector corresponds to the vector 3b vector minus a vector. Similarly, we can define EC vector. So EC vector is then going to become OC vector minus OA vector. That will be equals to, so we have OC vector given by 2a vector plus 3b vector minus, we need OA vector, so OA vector, that's A vector. So 2A minus A, that's going to be simply A. We have A vector added to 3B vector. So we have successfully showed that AC vector is defined by the vector A vector plus 3B vector by taking the help of the position vectors OA, OB, OC, and OD. Let's do one more problem. If the vertices A, B, and C of a parallelogram ABCD are defined by the position vectors A vector, B vector, and C vector, then determine the position vector of the vertex D. Let us begin. So first, let us construct a parallelogram ABCD. Now it's given here that in this parallelogram, the vertex A of this parallelogram is defined by the position vector A, which means that we have some origin of a coordinate system O. So if we join point O and A with the help of a vector going from O to A, then the position vector of that point A will be A vector. Similarly, we can define the position vector of the vertex B and C of the parallelogram. Okay, so let's note down the given information. So here we have the position vector OA, which is defined by A vector. Then the position vector OB is given as the vector B, and the position vector of the point C, that's defined as by the vector C. Our goal will be to find the position vector of the vertex D. That means we need to find OD vector. Okay, let us begin. Now, since ABCD is a parallelogram, so here we have AB parallel to DC, which means that if we want to convert it to a vector, then AB vector will be equals to DC vector. Okay, now how do we define the vector AB? So AB vector will be simply defined as OB vector minus OA vector. This will be equals to, we need DC vector, so that will become OC vector minus OD vector. Since we need to find out OD vector, rearranging the terms, we get OD vector will be equals to OA vector plus OC vector minus OB vector. We have all the required values. OA vector corresponds to the vector A, OC vector corresponds to the vector C, and OB vector corresponds to the vector B. So therefore, we have found out that OD vector will be given by the vector A vector plus C vector minus B vector.